Okay, so here we are on the last two questions. Let's come back to the box first. All we're doing here is just plugging things into this formula. And it's considered an exponential formula because you got this exponent up here and it's a negative exponent. But really, I mean, there's not much work to it. It's not much solving. All you're doing is just plugging things in. Here, so this is for amortization. This is when you take like a home loan out, or if you take a big car loan or any kind of big loan usually, then you pay it back in installments. And we call that kind of thing an amortization, an amortized loan. What usually happens is you have a monthly payment that goes partially towards the principal, the loan itself, and then partially towards interest. And then as time progresses, that goes more and more, like more and more is paid towards the principal and less is paid of the interest, so that you owe less and less over time. Okay, so here's the thing. M is the monthly payment. P is the loan amount. These R's, there's two of them, and both of them are the interest rate as a decimal form. So if it says 5%, that would be 0.05. And then T is time in years, always in years. So if it says months, then you got to convert to years before you plug it into this formula. So all we're going to do is we're going to look at the last two questions, and we're just going to plug it into that formula. Okay, so number 3 says Bendover wants to buy a new car for $23,000, the $3,000 down payment. He can obtain a 5-year auto loan at 4% interest. What will his monthly payment be? And then follow-up question, how much will he pay in total? All right, so what I'm going to do here is, let's look at the scientific calculator. I recommend the Desmos scientific calculator, or the Web 2.0 scientific calculator is also easy to use. Again, I do not recommend using the iPhone calculator because that one is junk. All right, so let's remind ourselves. I'm going to start by just writing out the formula again for my reference so I can see it clearly. M is P times R over 12 divided by 1 minus 1 plus R over 12 to the negative T. So M is equal to P times R over 12 divided by 1 minus plus R over 12 negative T. Yeah. And then I want to look at what are my values. So I have, he wants to buy a new car for $23,000 with a $3,000 down payment. So the first thing you're going to do is you're going to take your $23,000 and he's paying $3,000 up front. So that means he doesn't have to borrow the full $23,000, right? He has $3,000 himself. So he's going to borrow the remainder, the $20,000. That's going to be your P value. P is 20,000. It says the rate is 4% and it's for 5 years. So let's write those two things down. The rate is 4%, right? Yeah, 4%. And it's for 5 years, so T is equal to 5. Let's zoom out a little bit. Okay, so here's the formula up top. I'm going to erase this line so it'll fit nicer. I have my P, I have the R, I have the T. All I'm going to do is just fill in those values. Oh, it looks like it automatically did it for me, actually. That's kind of nice. I didn't realize it did that. Cool. Or if you're doing it by hand, then you just replace these with the actual numbers, right? 20,000, 0.04, 4, and T is 5. Okay. So the monthly payment is $368.33. Let's round to the nearest cent. That's $368.33 per month. That's the answer to the first part of the question. How much will his monthly payment be? The answer is $363. I'm sorry, $368.33. Now the second question though is, how much will he pay in total? Okay, so total meaning he's gonna pay this 368.33, 12 times a year because 12 because monthly, right? And he's doing that for 5 years. So altogether, he pays $22,099.80. And then you have to also tack on the amount he started paying at the very beginning. He paid the $3,000 up front. So in the end, he pays $25,099. And this is to buy a car that costs $23,000. So he ends up paying an extra about $2,000 extra by taking the financing. So it pays an extra $2,000, which is about 10% of the car cost. Yeah. Does that make sense to you guys? We don't hear you guys, so I'm gonna assume that it's okay.
Yes.
Okay, right on. Thank you. Okay, so last one, same kind of question, just this time with a home loan instead. So you're retarded, wants to buy a home for $450,000 with 20% down payment and 30-year mortgage at 3%. 3% actually, by the way, is the actual current average Hawaii rate, which is a really good rate. It's actually quite low right now. So what will his monthly mortgage payments be? What will the total of his monthly payments and down payment be? Okay, let's answer the first question, his monthly mortgage payments first. So we're using the same formula, right? But okay, let's just backtrack a little bit. Okay, let me just come back to the general formula. And let's just start filling in when we know. So the house cost was $450,000 this time. But he's paying 20% down, so you need to take 20% first. So times 0.20 is 20%. And then you're gonna subtract that so upfront. So what's happening is like you go to buy a house, right? And you gotta make a down payment. So this is money that you're assumed to have saved up or something, or I don't know. Maybe you borrow that too from somewhere else. I'm not sure. Anyway, so you pay the $90,000 upfront with your own money, and you end up with the rest. This is how much you're gonna borrow from the bank, right? That means your P is gonna be equal to that 360,000. That's how much you end up borrowing. Okay, now looking back at the question, the rate was 3%, and it's for a 30-year mortgage. 30 years is typical, either 15 or 30 years is how mortgages are done. So the rate is 0.03, and then the time is 30 years. Right? That's everything. And then now, the nice thing about this decimals calculator is it automatically, once I define my P, R, and T, it automatically fills it into the equation I wrote here. That's nice. So here's the answer right here, $1,517.77. That's the monthly payment. Let's just round to the nearest cent. So 1517.77. That's the monthly payment. Okay, that's the answer to the first question. What will the monthly payments be? The second question is, what will the total of his monthly payments and the down payments be? So that's kind of like the last question, same thing, right? We're gonna take that value that he pays monthly, 12 times a year, because monthly means 12 times, right, in 1 year. And then for how many years? 30 years. So altogether, that's 546,397. That's altogether $360,000 loan. Oh, plus the I forgot the question was how much in total. So plus the original 90,000 that was put as a down payment. Yeah, 90,000. Altogether, paid $636,397.20. That's to buy $450,000. So over the course of 30 years, you pay this amount to get something worth this amount. That's very typical, actually. That's this is not I know it seems like a really large amount, but that's actually how it does in fact work out in real life. In fact, 0.33, this is actually a good rate. So this is actually better than often you do. This is actually less than a lot of times that you would pay. But anyways, that's the last question. So that's it, guys. Just basically plug it into the calculator, right? I mean, there's not much more to it than that for this type.